we've got a box which is 20 by 15 by 27, and these dimensions are to the nearest centimetre. DVD cases are cuboids with a dimension of this, and here's another diagram representing a DVD case, and the dimensions of the nearest millimetre. Show that 17 cases stacked as shown will definitely fit in the box. I've drawn a box, and let's just consider putting the DVDs in horizontally. Have we got enough room? Now, show that 17 will definitely fit in the box. Because you see, the measurement of the box is not accurate. It's to the nearest centimetre. So if we're going to prove that they definitely will go in, we need dimensions for the smallest possible box size and the largest possible DVD. So to work this out, we're going to need the upper bound of each of the DVDs and the lower bound of the dimensions of the box. Let's first of all start with the box. The box, they say, is 27 by 15. So let's look at the 27. 27. Now they say that's correct to the nearest centimetre. So what's the next one up from that? Well, it's going to be 28. And the next one down, 26. Here are the goalposts. The boundary here will be 26.5. And the boundary here will be 27.5. And this is the lower bound. And this is the upper bound. Okay, now the DVDs themselves. The DVD is quoted, and the width of the DVD is 1.5. Quoted, as it said, to the nearest millimetre. Well, if that's in centimetres, this is 1 and 5 millimetres. So the next one up will be 1.6, and the next one down will be 1.4. Yet again, those are the bounds, and this will be the upper bound of the DVD's width, and this will be the lower bound. So as we've worked out, we're going to need the upper bound of the DVD's width and the lower bound of the box, and find out how many times this 1.55 width goes into this 26.5 width. So the number of DVDs possible must equal 26.5 divided by 1.55. Now pop that into a calculator and get 17.0967, and that goes on. So it can take just over 17 DVDs even at their upper bound. We've proved that the answer, that the maximum, rounding it up to single DVDs, is 17. And there is your answer. Let's just look at the other dimensions. We need to check that the DVDs will fit in lengthwise. 15 centimetres and this guy 14.3. So for the box, we've got 15. To the nearest centimetre, the next one up will be 16. And the next one down, which is the critical one, will be 14. Here are the barriers. And this is 14.5. And this is 15.5. So the critical one is 14.5. Will the DVDs be ever greater than that? So we need to check the comparable dimension of the DVD, which is 14.3. Next one up to the nearest millimetre, 14.4. And the next one down, 14.2. Again, the barriers. And as you can see, the maximum size of the DVD that we're interested in is 14.35. And our box is 14.5, so we were okay about the depth of the DVD fitting into the box. Now the last thing is the height, which is probably not so important because it looks like it's an open box and the DVDs will fit in, but they may stick out the top. But let's see if they do stick out the top. So for the box, we've got a quoted height of 20. Now for the DVDs themselves, the height was quoted at 19.2. And you can see even the tallest DVD, which is here, quoted at 19.25, will fit in the box so that it doesn't stick out the top, because the minimum height of the box will be 19.5. So we're okay, both from the height point of view and the length point of view, and we've already seen that the width allows us to stack 17 DVDs in the box. So we're okay.